Good morning, my dear friends. See now. I think this is the last problem in this chapter. We'll try to see now what is. This is a little peculiar problem. Okay. Please try to understand this. A concrete pile, 500 mm by 500 mm in section, is pre-stressed with four cables, each 150 mm square, the cables being symmetrically distributed over the cross section. Okay, in the sense, what he says is now there is a pile, okay, and its cross section is 600 mm by 600 mm, okay, and he has kept four cables which are symmetrically distributed. Okay, symmetrically distributed means I have shown it two here, two here. Okay, so the meaning of this is, Baba, you know that the cross section is also square one. So I can easily mark my CGC here now. Am I right? CGC can be now marked here now. And since the cables are placed symmetrically like this, CGS also lies here now. Am I right? So CGC and CGS lies at the same point. Okay, so here the eccentricity becomes 0. That is the meaning. Okay, here eccentricity becomes 0. I think you can easily calculate your YT and you can easily calculate your YB. YT is 300 mm, YB is also now 300 mm. Okay, so it's a pile. It's a PSC pile. Okay, so now I will continue with the problem now. Okay, the cables are symmetrically placed. Okay, the pile is 10-meter long. Okay, and is being lifted vertically by means of two wires which are attached to it at intermediate points 6 meter apart. Okay, and now what he says is this pile, okay, this is a pile of 10-meter long, 10-meter long pile it is now, and he says he wants to shift it to the site now. Okay, this pile is casted in the yard, and this pre-stressed concrete pile, it has to be shifted to the site. So what he does is now he has tied this pile with two ropes, okay, at A point and B point. He has tied them. Okay, this is the rope. Okay, by this rope he has tied at A B point, okay, which is at 2 meter from here and 2 meter from here. In a sense, at 6 meter apart he has tied these two ropes here now, and he is lifting it. He is now lifting the pile. Okay, and he is transporting this pile to the site. Okay, that is what the meaning is. See now, what he asks is, determine the safety of the pile during lifting if the compressive and tensile stresses in concrete are limited to 10 Newton per mm square and 0.5 Newton per mm square respectively. In the sense, whenever you are lifting the pile, then you have to check its safety, he says. And he has given the permissible compressive stress as 10 and permissible tensile stress as 0.5 Newton per mm square. Okay, the pre-stress in the cable is 1000 Newton per mm square. Pre-stressing in the cable is now 1000 Newton per mm square. This is what he has given by now. Okay, so now we shall begin with the solution now. Okay, as you see, Baba, as I have already explained you, okay, since the cables are symmetrically distributed and the section is also symmetrical, CGC and CGS coincide. Therefore, the eccentricity is now 0. The pile is lifted as shown in figure. So I have already shown this figure to you now. Okay, see now. Now what happens is, when the pile is lifted, see now, when the pile you are going to lift it, okay, now the pile is going to now bend like this. Am I right, sir? Now the pile is now going to now bend like this. In the sense, whenever you are going to lift it like this, okay, it will try to now bend like this. So compressive stresses are there at the top, tensile stresses are there at the bottom. Am I right, sir? Now whenever it tries to now bend like this, okay, compressive stresses are at the top, tensile stresses are there at the bottom. Okay, so now this is one thing. And second important thing is, now since you are lifting the pile, Baba, no live load is now acting on the pile. Am I right now? No live load. the live load starts acting when it is driven into the site. When it is driven into the ground, then only the soil pressure in the form of live load will start acting. Okay, but still, whenever I am lifting it, no live load is going to act. Only the dead load of this is now going to act on the this pile. Okay, so now since no live load is now acting, I have to analyze this beam in initial condition only. Okay, I have to analyze it in the initial condition, not in the final condition. Okay, so initial condition means the pre-stress will be in its initial form F, and no ML will act. Okay, no ML, only MD is going to now act. Okay, so now I think you can easily calculate its area. Area is 600 mm, 600 mm. Area can be, sorry, area I think it is okay. Okay, area can be calculated, and this moment of inertia but it is not 600, it is 500 mm. Okay, it is 500 mm by 500 mm. The cross section is 500 mm by 500 mm. It is not 600 mm 600 mm. Okay, sorry. So now the moment of inertia also can be now easily calculated. It is BDQ by 12. Okay, and but now he says that the now I want to find out the pre-stressing force F, initial pre-stressing force F. Okay, it is Fs into As. But by Fs he says that it is 1000 Newton per mm square initial pre-stress. As, but now he says there are 4 cables. Am I right now? And each cable has got an area of 150 mm square, he says. So 150 mm square into 4 such cables are there. This will give me the As into Fs will give me the pre-stressing force, initial pre-stressing force. It is so much. Okay, so now WD can be now easily calculated in the sense dead load UDL. Its area it is 0.5 by 0.5 into 1 meter along the span. Okay, 0.5 into 0.5 into 1 meter along the span will give me the volume. Volume into density will give me the WD. Okay, see now the pile is subjected to a UDL of 6250. Am I right now? So now the live the dead load is now acting like this on the this thing now pile. Okay, and now its intensity is now 6250 Newton per meter. So now at 6 meter apart you have tied the rope, you tied the chain or the rope. Okay, so now I will call this as reaction RA and reaction RB. Am I right now? So we shall try to find out this reaction RA and RB now. Okay, so I think you can easily find out the reaction RA and RB by taking the moments about B or A, anything. Okay, now I am going to take the moments about B point. Okay, now I think you can easily write RA into 6. RA into 6 will try to produce a moment in this direction, in this clockwise direction. So clockwise I have kept it as a plus. Okay, now I will take this load now, this UDL from here to here. It is 6250 into 8. 6 plus 8. 6250 into 8 will give me the total load, and its CG lies here now. Okay, it is going to act like this, and it is going to create anti-clockwise moment about this point. Okay, so now it is a minus 6250 into 8 into lever arm is now 4 meter. Okay, 4 meter. Now coming to this load, Baba, this load is going to create a clockwise moment about this point. So it is plus. Okay, so it's plus 6250 into 2 into 1 lever arm. Am I right? It is so much. This everything I should equate it to 0. The only unknown RA can be now easily calculated. RA works out to be 31250 newtons, or Baba, this itself I can call it as RB because of the symmetry, due to symmetry. Baba, once I know RA and RB, I think now I can calculate the maximum bending moment due to this dead load at the center. Okay, MD I can calculate. Okay, MD can be now easily calculated. It is RA into this distance, RA into 3, RA value I know, 31250 into 3, minus this load from here to here. It is 3 meter plus 3 meter, excuse me, 3 plus 2, 5 meter. 6250 into 5, okay, into 2.5 meter is the lever arm. Okay. Baba, this will give me a moment of so much, in the sense, at this central point, the bending moment due to dead load is so much. Okay. Now, as I said you, during lifting, Baba, as I have already shown you, during lifting operation, okay, compressive stress will occur at the top and tensile stress will occur at the bottom. Am I right? So now I will write the equation for top fiber stress Ft. Am I right? So now top fiber stress Ft is F by A plus or minus Fe/Yt by I plus or minus Md/Yt by I. Okay. You know the precessing force F, you know the area, and since eccentricity in this case is 0, CGC and CGS they coincide, eccentricity is 0. So now this term automatically vanishes, it becomes 0. MD I know and YT I know, I know. So it will become, its top fiber stress value becomes 3.15 Newton per mm square. Baba, now please try to understand now. Baba, this top fiber stress Ft is now plus 3.15 Newton per mm square. Okay. Top fiber, as I said you, whenever it tries to now bend like this, top fiber is under compression. Baba, the allowable compressive stress, he says that it is 10 Newton per mm square. Am I right now? Allowable compressive stress is 10 Newton per mm square. Since this stress at the top fiber is less than 10, Baba, now I say that whenever I am lifting this pile, top fiber is safe because this value is less than 10. Okay, so the pile is safe during lifting in a top fiber. Now similarly, we shall try to calculate the bottom fiber stress. Baba, it is F by A plus or minus Fe/Yb by I plus or minus Md/Yb by I. Am I right? Again, F value I know, A value I know. This term becomes 0 because eccentricity is 0. Baba, Md you know, Yb you know. Okay, so now this works out to be plus 1.65 Newton per mm square. Bottom fiber stress becomes plus 1.65. Baba, plus sign indicates that it is compression. Baba, bottom fiber, as you see, whenever you are lifting, bottom fiber is under tension. Am I right now? But in this case, you will see that plus sign is indicating that it is still in compression. It is not yet reached the stage of tension. Okay, so now, but allowable tensile stress at the bottom fiber is now 0.5 Newton per mm square. Okay, it has not yet reached 0.5 Newton per mm square. So now bottom fiber is also safe during lifting. Am I right? So now totally I say that the entire your pile is safe during lifting operation. Okay, thank you. That is how you can solve this problem. Okay, thank you.